Hello Physics Nation, my name is Nate Larmond and I'd like to do the third sample calculation associated with the do-it-yourself projectile launcher lab. At first we launched the projectile horizontally faster. Then we launched it at various launch angles. Now we're going to keep the launch velocity the same and we're going to see how consistent our projectile launcher can be. So this is like a design competition. You're going to compete to have the smallest standard deviation. Don't be intimidated by all the math. Honestly, once you know what this word means, deviation, the calculation is really simple. I tell my students I eat mayonnaise for breakfast. I just scoop it right out of the jar because I'm deviant. I'm far from average. And that's all deviation means, how far a measurement is from the middle of the set. So you're going to shoot your projectile launcher 20 times. I only did 5 repetitions here to make the calculation more simple, but you're trying to land this thing in the same spot over and over and over again. This experiment has a lot of historical echoes. This is a great YouTube video from Machine Thinking. This is a metal lathe from Vukason. He allowed cannons to be bored very precisely and pistons within steam engines to be machined very precisely. Anyway, projectile motion has a historical connection to precision. And I think that's why these labs are traditionally associated. So let's compare two sets. Set A, let's say the projectile went 7 meters, 5, 10, 8, and 10 meters. So the average of that is 8. You can say X bar or you can say mu to mean the middle of the set, the mean, the average. This set also has an average of 8. The projectile goes 5 meters, 8 meters, 2 meters, 15, and then 10 meters. But obviously the two sets are different. Range is one way to say how scattered or how tight or how precise a set of data is. Maximum minus minimum describes the spread as 5 for set A, and then maximum minus minimum describes the spread of the set as 13 for B. But there's a better way to describe it, and it's called standard deviation. So like I said, deviation simply means the measurement minus the average. It's how far the measurement is from the middle of the set. And you can see it's at the heart of the standard deviation calculation. So like I said, don't panic. This is just sigma. It's a Greek letter. We're going to take the square root of the average of the square deviations. All right, so let's take it 5 steps. We find the middle of the set, the average, then we find the individual deviations, then we square each of the deviations. Sigma just means add everything up, and then n is the number that are in the set. This just means find the average of the square deviations, and finally take the square root, and that's standard deviation. So let's apply this formula to these two sets. All right, these are the individual measurements. Here's the middle of the set. 7 is 1 below the middle. 5 is 3 below the middle. 10 is 2 above the middle. 8 is no distance from the middle, and 10 is 2 above. So now we square negative 1. That's 1. Square negative 3. That's 9. Square 2. That's 4. Square 0. That's 0. Square 2. That's 4. Find the average of the square deviations. That's 3.6. And finally take the square root. So the standard deviation of set A is 1.9, or 2 roughly. So the typical distance of each measurement is 2 above the middle. 2 above 8 is 10, and 2 below the middle. 2 below 8 is 6. So most of the measurements lie within 6 and 10. If you do the same set of calculations for set B, that is, find the middle, the average, find each deviation. 5 is 3 below the average, 8 is no distance from the average, 2 is 6 below, 15 is 7 above, and then 10 is 2 above. You square each one of those deviations, find the average of the square deviations, and finally take the square root. The standard deviation for set B is 4.4. So that means typically set B bounces around the average. 4.4 above, that is 12.4, and 4.4 below 8, 3.6. So most of the measurements lie in between 3.6 and 12.4. So what does this mean? Well, standard deviation describes the spread of the data. The smaller the standard deviation, the more consistent, the more precise, the more reliable the set is. And B is more scattered and less precise. Thanks for watching.